Hi everyone, my name is Alina. Thank you all for coming here. In fact, I know that there is one cat speaking in some of the other rooms, so I'm super happy and a bit surprised to see you all here. And in this session, we will talk about GraalVM and how it revolutionizes Java applications. And I hope that by the end of this talk, we will talk about various parts of GraalVM and how it's known for good startup time, but it's not the only thing that it can give you and your Java applications. So my goal for this talk is show you these other parts of GraalVM and Native Image specifically and how they can be helpful for you. So the first thing about GraalVM is, in a way, it looks a bit like this huge Swiss Army knife because it's a huge project and there are so many things with it that you can do that it gets a bit confusing. Even yesterday, I was at this unconference session about GraalVM, and before we got into details when to use and when not to use GraalVM, somebody decided we should mention which part of GraalVM we are talking about specifically because it's so huge that various parts work differently and it's a bit confusing when you should use each and what are the pros and the cons. Because of that, in this session, I want to focus specifically on this native image ahead of time compilation part of GraalVM, which takes your Java application and produces a native executable version of it. And the reason why you would want to build this native executable is because it no longer requires a JVM to run. So it starts really fast, it doesn't have high memory footprint, and you can just deploy it as is on a machine that doesn't have a JVM on. So just to get that out of the way, GraalVM is also a full-blown JDK, and all the tools and the libraries that you want to use, you can also use on GraalVM as a JDK. But the part that we will talk about today will be mostly around this native image and ahead-of-time compilation. And what makes those native executables really interesting for many people is that they are really good for cloud deployments because that is especially the environment when you want to have fast startup and low memory footprint. Okay, and those benefits, specifically the native image compilation part of GraalVM, is something that makes GraalVM really interesting for all those Java microservice frameworks, because specifically for microservices and serverless applications, you want to have those features where your applications start fast and use low memory. So because of those capabilities, many of those Java frameworks already adopted GraalVM as a platform. And if you want to build application with GraalVM, it's very easy to use one of those frameworks because they all offer support for GraalVM out of the box. Okay, so let's talk about Java in the cloud specifically and how GraalVM can help you improve your Java deployments. So one thing you want to achieve in the cloud, obviously, is fast startup, because you want your applications to be available to your users as soon as possible. And then when you want to scale, you want that also to happen as soon as possible. You don't want to spend that time starting up and warming up the JVM. So if you could have the same application but starting much faster, that would be a preferable scenario to have in the cloud. Now, the next thing is low resources usage, and that's interesting, I guess, for all the workloads, but more specifically in the cloud, where resources, and again, more specifically memory, is something you pay for. So if you could deploy the same application, but use fewer resources to run it and keep it operational, again, that would be something preferable, and especially in the cloud. And another interesting part of native image, which I think is not talked about enough, but for me it's very interesting, and this is something that I always pay attention to, is that there are ways in which native image and GraalVM can make your application more secure than running on the JVM, and we will look at that later in the talk. And the last thing, again, for the cloud, if you can minimize your packaging size so that you can deploy and scale your applications faster, that will be also preferable. So let's see if GraalVM can help you to achieve all of those goals for Java applications. And first thing, let's start with startup time. So how does that GraalVM achieve that fast startup time, and how does it actually produce a native executable of a Java application? Because normally, usually, Java applications are very dynamic. There are a lot of things happening at runtime, and that's something that makes the Java platform very powerful, but also that poses a challenge if you want to compile things ahead of time. So how does that actually happen? When you run the native image build process, so you run the native image command, and then you give to it your application in a bytecode form, what happens is that it will look at your application starting from its main entry point, and it will try to find all the reachable code. So all the code that is necessary for your application to operate and eliminate everything else. So only the code that does something valuable that contributes to your application functionality will be included in this native executable, and then the rest will be eliminated to make this executable small and lightweight and efficient. And this applies to your application code, but it also applies to the dependencies that it's relying on and the GDK classes. So it will try to find all the reachable code so that it can include it in the binary and eliminate everything else. And another big part of the story is it will also perform heap snapshotting. So it will prepare this pre-populated heap that your application can start with to save some time and memory when you actually run in your application. So the whole idea here is to kind of break working with your application into two stages, when one is the runtime, and before that comes the build time, and try and move all the heavy lifting, all the expensive operations from the runtime to the build time, so you can do them once and not have to do them every time when you start your applications. Because most applications are started way more often than they are built, so it makes sense to do it once when you build your app and then run significantly faster because all that overhead has been removed already. So what you get in the end is this native executable version of your Java application, and it can start really fast, and it doesn't need a JVM to run. What's important here is because it's native executable, it's platform specific, so you would need to build it on a machine with the same operating system and architecture as you're planning to deploy it, or use something like CI/CD, but that's something to keep in mind because it's a native application, so it needs to be built on the same platform. Okay, and if you compare those two execution modes, so if you compare running on GraalVM Native Image versus running on a JVM, and JVM in this case can be GraalVM, can be OpenJDK, doesn't really matter. We are talking about execution modes. So what happens when you start your application is the following. When you run an application on a JVM, there is quite a bit of work to be done when you start your app. I'm sure you noticed that when you actually start your application first. So you would need to load your classes, start interpreting, start compiling, and all of that takes some time and takes some resources until your application reaches its warmed up state when it actually runs with the best possible peak performance. And that takes some time, but actually it can also happen that not all of the methods are executed as compiled here, because some methods never reach that compilation threshold. So it could be that some methods here are still executed in interpreter mode, and that is significantly slower. But at some point, your application reaches this warmed-up state, and it can run with the best peak performance. Now, when you run the same app, but compiled to native executable, what needs to happen in terms of startup time is that you would need to load the executable itself, and then you would need to just execute your application. It doesn't need to do all that code compilation overhead because it already has happened at the image build time. So that is startup time. And I also want to talk about resources usage, and then we will show some demos to illustrate those two things. So in terms of resources usage, if you're, again, executing the same app on the JVM versus in the native image mode, on the JVM, if you're running your app, you need to keep memory around for all those things that are kind of your code execution infrastructure, because you need to be able to execute that code dynamically at runtime. While on the JVM, we don't need that code execution infrastructure. Everything is compiled. So what we need to keep around is this minimal VM components kind of implementation, so very minimal runtime that is embedded in your native executable, and the actual application payload. So even visually, without, I don't know, reading much into it, I think you can compare how different those two things are and where those differences in terms of startup and memory usage are coming from. And this gets even more interesting if you want to scale such an application. So let's say we want to scale by adding more instances of each. So on the JVM, you would need to scale memory by adding more memory for all those components. While if you want to scale in the native image mode, you would need to scale for the application payload itself. And to make this a bit more illustrative, here is kind of the same thing, but running on the actual application, which is Quarkus Apache Tika. So here we're trying to scale the same application, again, running on the JVM and in native image mode by adding more instances and then measuring the memory. And the yellow bars, that is running on the JVM, while the red ones, that is running in native. And since native executables, as native applications basically, can share some things between them, it's more efficiently to scale this way, but also because, again, you don't need to keep memory for all this code execution infrastructure. So if you want to scale such an app, it's easier and it takes less resources. Okay, let's look at some demo now. Okay, the first demo I have, where is it? Okay, simple demo. And it's a micronode application. And what happens here, it's our main application class. Let me see if I can expand this. And also I have a controller here with the endpoint hello, which returns this hello devox. So let's run this. And let me maybe move this higher up and clear this. So it's a micronode app. Let's run it. This will run it on the JVM. Okay, it runs. We saw some metrics here. So for example, startup time completed here is in 500 milliseconds, and it's running on 8080. So let's go there and check out our app. Let me just remove this. Localhost 8080, and our endpoint is hello. So it says hello devox. All good, it works. Not doing anything crazy, but it works. And this was running on the JVM, and notice the startup time, it's 500 milliseconds. Now, what I also have done already is that I have this app compiled to native. Here it is. So here is my simple REST app already compiled. So let's run it. Okay, I think you can see even visually how much faster it started, but also if you pay attention to the startup time reported by the framework, it's 23 milliseconds. So let's go and check that the app is doing the same thing. So localhost and then hello, and it's doing the same thing. But this is just startup, so maybe those numbers I would say look significantly better, right? But this is just startup, and this is reported by the framework, and maybe we are interested in something more meaningful. So maybe what we want to measure is starting, but actually doing something valuable, such as serving our first request successfully. And for that, I will switch to a number of scripts that I have here. So for that, I will have my switch to help me switch between modes quickly. So this is just to switch between JVM and various native image execution modes. And I have a number of scripts to test both of our apps in different modes. And the first one is start script. So this will just start our app in whatever mode we specify when running the script. It will wait for the first request, and it will take the process down. And this way we can measure startup more meaningfully, so serving something, but also externally, so not relying on the framework data, but just looking at it from the outside. So let's do it, and let's do on the JVM. Okay, so it started our app in the JIT mode, and the total time elapsed, so both to start but actually serve this request, is 1.14 seconds. This is on the JVM. Let's do the same by doing native. And it's significantly faster, right? So you can see it's 0.09. But that is startup time. And as a developer advocate for GraalVM, sometimes I hear, but okay, I don't care about startup. You know, maybe my app starts once in a while. Maybe I don't care about it much. Do I still need to do native image, or why should I? And here I would argue that for me personally, I mentioned that I care about security, but also resources usage might be even more important, right? So maybe your application indeed doesn't start that often, but especially if you're deploying to the cloud, you might be interested in reducing that resources usage. So for that, let us run our application again, and again in both modes, and let's observe its application behavior in terms of using CPU and using memory. And for that, we will use the tool called PS Record that will output it to us in a nice visual way. And here we will actually send several requests over the time to see how our app performs over the time. So let's do this, and let's do JVM first. So this started our app, and now it's sending some load. As a result, it will output a nice visual chart of the app performance for us. Okay, so it's done, and this is the last added file. So this is it. And the way to read this is that this blue horizontal line, that is memory usage, and then the red vertical ones, that is CPU usage. So you can see that memory used here is around 200 megabytes. And then in terms of CPU, something interesting happens here until I would say the first, I don't know, 1 second maybe. So you see that the CPU is quite busy because there is all this work of loading and executing your code going on. So executing, loading, interpreting, compiling. So it's quite busy in the beginning, and then once in a while we get a few more spikes when our requests are arriving and being served. So this is on the JVM. Let's see how, again, the same app will do in native image mode. So this is running, again, sending several requests, and we will have our new chart in a second. Okay, we are done. And this is the other one. And you see that here it's a bit different, right? So memory usage is lower at first. And yeah, it's easier. You could have gone even lower in terms of memory usage. We will not do it here, but it is possible. So memory usage is already lower. And what's interesting, you can see that there are no CPU spikes anymore because there is not that much work to do because we already compiled it and optimized it ahead of time. And I think that this makes native image a good deployment model for something like web servers, which need to be efficient in a way that when there's no load, they should not take up a lot of resources because there is not much to be done. So when there is no work to be done, they can be idle without wasting resources. And then when it actually arrives and needs to be served, they are available without wasting any additional resources. Okay. So this is startup and memory usage, but we all know and love and use Java for the best possible peak throughput. That's what it's famous for. So how does native image perform in terms of peak throughput? Let's give it a try. And for that, we will use a tool called Hey. Where is it? Load. So we will use Hey to send 1 million requests to our app. And we will see if our app can take a bit more significant load. Let's do it. And again, let me bring this higher. So now it will take not a lot, but a couple of seconds because it needs to serve all this load. Okay, we are done. Here's our response time histogram. But for me personally, it's always more interesting to look at peak throughput numbers. So what we got here, and again, this was on the JVM, we got 105,000 requests. Maybe it's good, maybe it's not. I would say objectively it looks good, but to get a better idea, let's compare with the native mode. So again, doing the same thing, just this time we started with the native executable, and again, sending 1 million requests to our app. And we are done. And again, 200 status codes for our responses. That's all good. And in terms of peak throughput, we see that it's even a bit higher than we had on the JVM. So obviously, this is probably not the best and not perfect benchmarking setup. Probably I could have done this in a cleaner environment. But the bottom line here is that in a peak throughput, in terms of peak throughput, in the native image mode, we can also do quite well. So you don't need to necessarily give up peak throughput if you are doing native. You can get startup, you can get memory usage reduced, and you can also get peak throughput. I do need to mention here that here I'm running on GraalVM Enterprise. So if I want to achieve the best peak throughput, I do need to use some features that are in GraalVM Enterprise. There are some additional compiler optimizations, and also there are more features available, such as profile guide optimizations and another GC, which is G1 based. So there's another edition of GraalVM, which is Community Edition, that can also give you good peak performance. But if your absolute goal is to achieve the best peak throughput, I do recommend at least evaluating GraalVM Enterprise and seeing if that will help you achieve that goal that you have. There are more things that I can do with it, actually. So here we're just running our plain native image compiled without any additional boosters. But there is this thing called profile guide optimizations. And that is an optimization that allows you to build an instrumented version of your native executable, apply relevant workloads, and this way collect profiling information so that native image can build an application that is kind of aware of the runtime behavior and this way optimize for the best peak throughput. Because the way this is done on the JVM is that as your application is being executed, the JVM also collects that profile information and adapts on the go. That is why it's so great for the best peak throughput in addition to GCs and other things. But native image compilation happens ahead of time under closed world assumption, so by default, there is no way of knowing what happens at runtime and adapting to that behavior that is possible only at runtime. So this optimization is kind of combining the best of two worlds. You are getting ahead of time compilation, but also you're getting an insight into what happens at the image runtime, and this way you can optimize an app for the exact runtime behavior. So for that, I also have one more version of this app that is already compiled with this optimization in mind. And that is, where is it? It's called Simple REST Optimized. So it's already compiled with profile guide optimizations. So now if I run it, so we are doing the same test, sending 1 million requests, only this time we have an optimized version of this native executable. So optimized to the best possible, probably peak throughput. So before, I think we had 108K on the JVM and something like 110 on native image out of the box. And here we are achieving even better peak throughput. So if you want to achieve the best possible peak throughput, I do recommend that you check out profile guide optimizations. And one more thing that could be helpful is using G1 GC. Okay, so that was startup time, memory usage, and optimizing for the best peak performance. But what else is there in native image, and why else could be interesting for you? So as I said, this is something I often talk about because I think it's very interesting how native image eliminates certain vulnerabilities just by this ahead-of-time compilation. And the way it does so is the following. So when you're running your native image application, no new unknown code can be loaded at runtime because there is, as I said, no longer this runtime code execution infrastructure. Everything needs to be known at the image build time. It happens at the closed world assumption. So no new dynamic unknown behavior can be happening at runtime. And it can be seen as a limitation, but also I would say it's more of a probably design choice, and it opens other opportunities because this way, this random code cannot be loaded at runtime and cannot do things that are unpredictable because there is just no new code execution at runtime. And another thing that only the code that is reachable, it will be built in this native executable. So if you're building an app and you're using maybe a lot of dependencies and you're not so sure about some of them, and maybe you're using just a fraction of some of them, only the code that you're actually using will be included in native executable to make it small, to make it slim, but also it will just eliminate everything you are not using. And we will see that in a bit, but things like reflection and other dynamic Java behaviors, such as serialization and proxy usage, by default, they are disabled, and they need to be enabled via configuration. So configuration be coming from you, from framework, from a library, but those things by default are disabled. And same applies to serialization. And in a way, it's a limitation, but again, it gives you more control over what happens at runtime, and it gives you those additional security guarantees. And last but not least, certain attack vectors, specifically around just-in-time code compilation, are not possible in native image by default because there is no just-in-time code compilation when the application actually runs. And for that, I want to show you one more thing. So I have a demo which is called Unsafe Demo, very fitting, I think. And what happens in our unsafe demo is the following. So here is our app. This is our main application class. It's, again, a Micronaut app. And we want to, this will, again, will be a web server, and we want to serve some static content that is over here in the resources folder. We have this no-brainer hello HTML file. So let's say that's an existing functionality that we have in the moment. And we also have our application YAML with some properties of our app, including, for example, our database. So let's run this app. It's, again, a Micronaut app. So let's do this. Okay, it runs. It's at 8080 again. So let's go and let's check it out. And it's supposed to serve this content from the static folder. So let's see if we get our hello HTML. We got it. All good. But let's say maybe something changed on the team. I don't know, some new employee joined and they decided to implement this logic in a different way. So instead, they want to have a get endpoint, and then they want to serve this hello file by retrieving it by name. So maybe they came up with that logic on their own, or maybe they copy-pasted it from some website that we all know. But let's see if this logic also works. So if we go to get and we get our file by the file name, okay, seems to be working all good. And at this point, let me switch to curl so we see a bit better what happens over there. So let's say I want to curl that endpoint, and let me just wrap it into quotes and do like this. Okay, seems to be working here, all good. I mean, we are proper developers, we want to test this, so let's curl some nonsense and see what happens. So this is also seems behavior, the behavior is correct, right? So what is supposed to be working is working, what is not supposed to be working, it's not working. Looks perfect, let's ship, let's deploy. Do you think there is any problem in this code? Let me just go back to the actual code. So this is my controller. Do you think there is any problem here?
You could put a couple of dots in the path and go off the level.
That was too easy. But let's actually try your way and see if it works. So let's do this. And indeed, because the user input here is not sanitized in any way, I could do something like this. Application YAML. And I have my application YAML file along with the credential to my database. So obviously this is not ideal, and probably this is not production worthy, but I think we all wrote at some point some code that maybe wasn't ideal and production worthy. So here's my application file, and it doesn't stop there. So one more thing I could do, I mean, this would probably take some, I don't know, guessing or insight, but what's my package name? So if I go example, and I go Micronaut, and go hello controller dot class. Okay, seems good. I don't have the actual input here, but this would have given me the input. So again, not great, but let's see if there is something we can do about it. So again, I have this app compiled in Target. Here it is, my Micronaut app. So let's run it as a native app. Target, where is it? Micronaut guide. Okay, it's on, and let's do the same thing. So if you go to localhost 8080 static, the old way we were serving the file, it's all working. If we go and curl it by name, this one. Okay, it serves my file, all good. But then if I'm trying to curl my application YAML file, it gives me nothing because there is no longer an application YAML file. It's all been compiled and put into this native executable. And if I try to get my class file, again, nothing happens because there is no longer this directory with those class files. So this is just one of the ways, but I think it's really interesting and fascinating and not talked about enough, the way how native image can also give you additional security benefits on top of that startup and memory usage benefits. Okay.
Return the executable though, put back in?
Can you repeat, please?
Would that still return the executable if you have the name for that file?
That's interesting, but sounds dangerous to me. Do you mind if we try it out after the talk? Okay, let's go back here. Yeah, done. And I did want to mention this is actually being used by real teams and organizations. So we have our fellow team at Oracle who is using GraalVM with Helidon to build microservices, and they said that yes, this startup memory usage packaging size, that's all great, but what they really care about is the security angle. So I'm glad to see that there are people who are actually doing this in production for security purposes. Okay, and I briefly mentioned compact packaging, so I want to say a few more things here. So what you get in the end with native image is this native executable that has all the necessary code. And it also eliminates all that code that you don't actually use to make it as small in terms of packaging size as possible. And there could be a disadvantage in a way that you cannot share the Java runtime, but it also means that if needed, you can patch and replace those native executables individually. And if you want to take the packaging size to the absolute minimum, there is a long way and many steps of what you can do. So here we are looking at container size of the same application, just packaged differently. And this is all on GraalVM, so on JVM versus native image. And the red chart, the red bars here, that is running on the JVM, and the green one, that is native image. So if you want, you can build a fully static native executable that will be smaller, but then you can use a tool called UPX, and if for some reason you care about the packaging size the most, so maybe you're running in a very resources-constrained environment, you can use UPX to compress your native executable to the absolute possible minimum. So you can go to something like, I don't know, 5 megabyte size, which is pretty crazy for the fully working application just compiled as a native executable. Okay, that sounds all good and maybe too good. So if I were you at this point, I would be thinking, okay, there must be a catch because this just sounds too good so far. So let's talk about the catch. GraalVM and reflection. I'm wondering if somebody here in the room have heard that GraalVM doesn't support reflection. Okay, this is better than I usually get because usually more people say that they heard at least that GraalVM doesn't support reflection. And that is not exactly true. GraalVM does support reflection, but there are things to be aware of, and they are the following. So we mentioned that GraalVM native image compiles things ahead of time under closed world assumption. And what this means is that all those more dynamic Java features, or as some other speakers, as Josh Long called them, all the fun features in Java, pose a bit of a challenge to that closed world assumption and ahead-of-time compilation because it's very dynamic and there is no way of knowing what happens exactly at runtime. So specifically for reflection, what happens is that native image tries to resolve those reflexive calls automatically. So for some more expected, more basic reflection API calls, native image might figure them out of the box. So this is not something you would need to configure. In some cases, it will work out of the box. In cases it wouldn't, what would you do? There is one more thing that you can do, and that is we have a tracing agent that is shipped together with native image, and that's a normal Java agent that you can run with your application on a JVM, observe its application behavior, and it will produce this configuration that will help native image build your application with those dynamic features in mind. This is done in a way to eliminate that manual work for you. So you can run with the agent, it will produce config files for all those things like reflection, proxy, all kinds of things. One thing to be aware of is that we do not claim that it's a silver bullet, so you might want to check out the produce config and make sure that it's complete, but at least it will eliminate most of that manual boring work for you. So this is something you can do like on your end. And then, luckily, many frameworks and libraries already adopted native image as a platform. So if you look at some of the libraries, for example, just yesterday I was looking, I think, at H2. And if you look at the source code, they already ship config for native image out of the box with the library itself. So this is something that will just work out of the box. But then not all libraries yet have adopted native image and ship this configuration for native image. So the next best thing we can offer at the moment is this centralized reachability repository that is on GitHub. And that is a place where our team and various people in the ecosystem, such as framework team and library teams, they contribute this config for native image in there so that other users can reuse it and benefit from this centralized place instead of for everyone figuring this out on their own. And what is great about this repo, I mean, still doesn't seem very easy to use it, right? So if you are using our Maven and Gradle plugins from the GraalVM team, they're called native build tools. They have an integration with this repo, so you can pass there a parameter saying, hey, I want to discover configuration from this repo. And what this will do is at image build time, they will go to this repo and will try to pull config for your dependencies from this repo automatically for you. So those are the ways to approach reflection in GraalVM and more specifically in native image at the moment. And I do want to show you just, I don't know, for fun, manually, how you can configure reflection. So let's do it. For that, I have another app here. Where is it? I think here. So this is my app. This is my main class. And what is happening here is we are trying to go and access this message field from this message class. So the one over here. And we are doing so reflectively. So maybe in a slightly obvious and slightly less obvious and simple way. And the way we are doing this so untrivially is to try and confuse and outsmart native image, because if this call was a bit more predictable, native image could figure this out on its own. But for the demo purposes, we are trying to go ahead and confuse and outsmart native image. So let's see if we can make this work. I just want to move to the right place. Okay, here we are. So one more thing to know about this app. Here is my POM.xml. Where is it? Over here. And here I have my native Maven plugin coming from Native Build Tools. So this is the official plugin for building native applications from our team. And what I have here, somewhere I have my agent. So this is the tracing agent that I have, the one that I mentioned that will help me produce this config. But let's try building this without the agent first. So this is set to false. And just in case, let me double check my target directory and my native config. So this is the place where I would normally have my configuration. Let me remove this for now. And let me try building this app. This is not nice, but let's skip test for now. And we want to package. What? I missed. Oh, okay, let me kill this, which is not smart, but that's a good catch. I didn't see that. Okay, so do you think, would this build or not?
Yes.
Yes. Okay, that's an optimistic way to look at things. Usually people are not so sure. Or they expect a trick, because if the speaker is asking, would this build? Most likely it will not. But this has built, so let's see what it does actually at runtime. Target example app. And we're getting this message that reflection is not working. And that is what we catch over here when we cannot figure out this reflective call. So let's see if we can make this work. And for that, I will go back to my POM.xml. I will enable back the agent. So I'm setting this to true. And I have my helpful script somewhere, so I don't need to type all of this, but this will just run my app on the JVM with the agent to produce the config that I need. And the config that I need is the one here, reflect config.json. So let's run our agent. So this was very fast because we were skipping the native build. We just ran on the JVM. And if we go back to our reflect config, I don't know if you remembered, but previously I removed that, so it was empty, and this is actually the output that I got from the agent. So this is not too scary, I would say. This is something you could write manually, but it's probably not too exciting to have to write something like that. So it's better if it's produced by some tool, such as, for example, the agent. So our agent is back. Let's go ahead and try to build this again. I think you can also appreciate how much work Native Image is doing at build time, because this app, it's not even that big, but you can see that, for example, here we registered, what, 3K classes, just the ones that are reachable, so just the ones that are needed for my application to work. So that is a lot of work that is happening when I compile this application back and forth. But this is done, so let's see how it works now. Example app. So now it's actually working. We are getting our message that is coming from that message class. And that is how you would configure reflection manually. But hopefully, this is not something that you would have to do yourself. This can be provided by the framework, by the library, from the reachability repo. This is just to illustrate the point, but I do hope that you would not need to do something like that manually. Okay, and another thing about native image, so I mentioned that we are no longer running on the JVM, and the native executables that we are producing are platform-specific. So that means that you would need to build the application on the same architecture and operating system that you want to run your application, or use some kind of CI/CD system that will do it for you. And also, as I said, there is quite a bit of work to happen at the image build time. So you do need more or less powerful machine to be running this, because it's not trivial to take something so sophisticated and dynamic as a Java app and compile it to native image. To approach that target architecture and operating system issue, you can run GraalVM with something like, for example, GitHub action, and we have our own GitHub action, and it's actually possible since quite a few releases ago to build something even more complicated and bigger, such as, for example, Spring Pet Clinic on GitHub actions. So memory and resources that are available there are sufficient to even build something bigger. And actually, you can go even further, and if for some reason you need to build on a machine that only has 2 gigs available, it is possible as well, even for slightly larger applications. What I do want to recommend here is, if a build time is a concern, it's not on the slide, but there is a flag that you can enable, which is a quick build mode, and this will speed up the compilation step. So not the whole build process, but the compilation step, but at the cost of a runtime performance. So this is only intended for development purposes. If you want slightly faster feedback loop, you can use that -OB quick build mode flag. Now, another thing to do about build times is to develop your application mostly on the JVM and then compile to native as a more or less, I don't know, not the last step, but once in a while in your development cycle. You don't need to do this on every single minor change, especially if that change is around business logic and not something more kind of low level and technical. And as I mentioned, if you want to achieve the best possible peak throughput, in addition to startup, memory, usage, security, packaging, etc., you do need profile guide optimizations. And I want to use this chance to briefly talk about what's new in GraalVM. So we are trying to keep up with the latest Java releases, and we have dedicated 20 developer builds available. So only developer builds at the moment. We are still waiting for our normal production-grade feature release in June. But if you want to try the latest Java features with GraalVM, this is available as a dev build. So this is something you can use and actually get an idea of the features that will be available in the next release in June. And in terms of how developer experience changes around native image specifically, so we are working to enable more monitoring features. And this is something where we actually get quite a bit of support from the community. So thanks for that. We are building now JFR support. JVM stat became available in the last release of GraalVM. So now you can observe application behavior in something like Visual VM as well. And what is coming up next as an open source project, we have this public roadmap on GitHub. So that is where we can see how we work on certain things, what is coming up soon, what is planned for later, and you can share your feedback with us and let us know what features you think we should prioritize. And one more thing that I want to mention specifically, I cannot talk much about what's coming up in the next release, but this is more or less public. So we are bringing ZGC support on Hotspot. So in GraalVM on the JVM, not in native image yet, but if you wanted to use GraalVM as a JVM and you needed ZGC, so this is coming up in the next release. And talking about native image specifically, so what is happening there and what is coming up next, we are working on simplifying configuration and compatibility for Java libraries. In fact, here I wanted to show you this page that we have on the website. So I mentioned reachability repo. That is where we have configuration for many libraries and frameworks on GitHub, but also we have this page on the website. And this is for the cases where people would ask me, how do I know if I can use native image? So I have certain dependencies, and how can I know if they work with native image or not? So this is maybe not a complete list. We are still accepting contributions, but this is a good place to go to learn which libraries work with native image already. So either by having all the config shipped alongside the library or by pulling it from the centralized repo. And here you can see over, I think, 100 various libraries and frameworks that already work with native image out of the box without any of that manual work magic necessary from you. So if you want to check if you can build a certain thing and run it on GraalVM Native Image, this will be a good place to go. And in addition to libraries, we always keep improving peak performance of native image, and we are working to reduce both build times and memory usage of the native compilation process itself. So to get started, what you can do, you can use this script to get the latest GraalVM downloads from our website, or if you're using SDK Man, it's also very easy to get GraalVM from SDK Man as well. And last but not least, this is not all of the GraalVM content here at Devoxx. So I think after this talk, we have a mini lab with our colleagues, so you can go and try to build some of this practically yourself. So what I think that we want to accomplish is to show you in 1 hour how you can start, build a Spring Boot app, I think, as a native image, then deploy it. I don't know how you plan to do it in 1 hour, but if you want to see us trying, come and join our mini lab. And then tomorrow I'm talking with Josh about beautiful Spring Boot. So that will be fun. Join tomorrow as well. Okay, so just to summarize all this, if you want to achieve a fast startup, if you want to have low resources usage, more specifically memory, if you want to minimize vulnerability of your apps and get packaging size, then at least try native image and see if it works for you and if it helps you accomplish your goals. That is that. That's my name. That's my Twitter handle. If you want to ask some question and you would rather do it privately, my DMs are open so you can do it. With that, that's it. I will stay here if you have any questions, and please evaluate this talk in the app. And thank you all for coming. Thank you.